Welcome back, Fremont third graders. Today in math, we are going to be working with money, and we are going to look at how much change we would get back if we give the cashier a certain amount of money. So they will all be subtraction problems today. So our first problem says, at the grocery store, you spend $1.49. And I would read that $1.49. So we're going to remember that, and we're going to try to find out how much we'd get back if we pay with two $1 bills, with a $5 bill, and with a $10 bill. So first I'm going to solve for spending $2. I'm going to write my traditional algorithm, and you need to be careful and make sure you line up everything in the correct spot and keep those decimal points in the correct spot to help you solve. So I set it up. I'm going to make this just like we've done our other problems. I'm going to make my $2 over here, and I'm going to put my $1.49 on this end. And for right now, I'm going to ignore my decimal point and just think of this as 149 and this as 200. So I want to get to my first benchmark. I'm going to add 1 to get to $1.50. To go from $1.50 to $2, I know that that's just 50. So this would be like saying 51 cents. I can write it 51 cents, or I can write it $0 and 51 cents. Either of those would be correct. I'm going to check my traditional algorithm. 0 minus 9, I can't do. I have 0 tens, so I cannot trade. So I need to go over to my hundreds place or my $1 place. Then I can give this 10, because 10 tens is the same as 100. Now I have one that I can trade to give to my ones place. 10 minus 9 is 1. 9 minus 4 is 5. My decimal points stay right in the same spot. 1 minus 1 is 0. So again, I have $0.51. So we're going to say we're using the same amount of money, $1.49, and this time we pay with $5. So I'm going to set up my traditional algorithm first. And these are related problems, so I should have pretty close to the same answers just with my dollar amount changing, because my dollar amount is changing in my question. So I have my $5, and I'm going to take away $1.49. So again, I'm going to put my $5 on this side, and I'm just going to pretend that that's 500. My $1.49, or my 149 is on this side. Again, I'm just going to add my 1 to get to 150. 50, I'm going to add another 50 to get to 200, or $2. So as you can see right now, we're the same as this one, except we're going from $2 to $5. So I'm going to pretend that this is 200 to 500. I would add 300, so that would be 300. Sorry, I made a mistake there, 50. 351. So that could be 351 cents. Or if I was putting it in dollars and cents, it would be $3.51. Checking with my traditional algorithm. Again, just like my previous problem, I have 2 zeros. I cannot take 0 minus 9. I need to go to my dollars or my hundreds. Make 10 tens. Now I can trade. 10 minus 9 is 1. 9 minus 4 is 5, just like our previous problem. Except this time I do have more dollars, and I can take $4 minus $1 is $3. So $3.51. So now this time we are taking $10, and we are still only spending $1.49. I really need to make sure that my places are lined up correctly. Subtraction, not addition. And if I'm thinking about this, if this was $3.51 and that was only $5, I know this is 5 more. So my answer, I'm going to guess, is going to be $8.51. But let's check our work first. I'm going to put my $10, my $1.49. We already know how to get to $5 by 351. So I'm just going to do just add 351 because this is again is a related problem, and that's going to get me to my $5. And then to go from 5 to 10, I'm going to add another 500. So 500 plus 351 is 851 cents, or I could say $8.51. Again, I'm going to check my work one last time. I have 0 ones, cannot take away 9. 0 in my tens place, cannot take away 4. I still have a 0, but I'm going to look at this as a 10. I can make this all a 9. Now I have 10s that I can trade. 10 minus 9 is 1. 9 minus 4 is 5. 9 minus 1 is 8. And my guess was correct that it was going to be $5 more. So I would end up with $8.51. What I would like you to do now is to try problem number 2 on your own.